Hey everybody, this is Mr. Munson, and here we are in G4.2, special triangle segments. Now this up here shouldn't have that point 2 because we're in the unit G4, triangle relationships. Okay, triangle inequalities, relationships. I keep on changing it, but it doesn't matter. In any case, we're going to run through in this video several special segments that you're going to be able to identify given certain information in a triangle. And you'll need to be able to identify it. And each one of these special segments that we're going to be adding to our vocabulary list are going to have these relationships that are going to be formed between sides and angles, and we're going to have to practice enough that we get to a point where we just know these relationships. Let's go ahead and get started. All right, let's go ahead and start in our notes. That should say 4.2, shouldn't it? Okay, so we are in 4.2. We're going to call this special segments. First one that we're going to look at is an angle bisector. Okay, so now I'm calling it array here, but if I was to have it stop and not continue on, it would be a segment. It's easy enough. A angle bisector cuts an angle into two congruent parts. Now I want to draw your attention to what I've written as lowercase letters here. These lowercase letters represent lengths of segments on the outside of this triangle, okay? Now this bottom one has been broken up into two lengths of D and C. That's going to be important as we get to this next idea. So here's the list of characteristics that an angle bisector you should know. It creates two congruent angles. Each angle has its own angle bisector. That means there's three of them in this triangle. C has an angle bisector, A has an angle bisector. They're not drawn here to keep the drawing simple. They all meet at one place. So if I was to draw my angle bisectors, they would all meet in one place. And it creates a proportion. Now that proportion is going to be A over D equals B over C. Now take a look what that says. That says over on the left-hand side, A is the length of that side. That ratio between A and D should be equal to the ratio of B and C. Now this is going to be helpful because if I have an equation with four things running in it, as long as I know three of them, I can find the fourth one. And it doesn't matter which one is missing. As long as I have three of the other pieces, I can find the fourth one. And we'll work on some problems to make sure you understand that. This next segment is called a median. It is a segment that comes from a vertex, okay? So a vertex is a corner of one of the triangle, one of the corners of the triangle. And it goes through a midpoint. So each side has its own midpoint. So here's this midpoint. I can tell it's the midpoint because on either side are two congruent segments. So that's called a midpoint. Each side has its own midpoint. And therefore, going from each angle through that midpoint would give me another median. And from this one here, A, there's some midpoint over here. And guess what? They all meet in the same place. So there's three medians in this drawing. But for the sake of your notes, let's just keep it that one so you can have an idea what it is. Let's look at the characteristics of that drawing. All right. Well, first of all, the median bisects each side. Each angle has its own median, and there are three medians, and they all meet at one particular point. Now let's take a look at an altitude. An altitude is a perpendicular, so we have to make sure that we understand that word. Remember, a perpendicular is a segment. Two segments are perpendicular if they meet and form a right angle, okay? So that's what's going on down there. So it's a perpendicular segment that comes from a vertex to the opposite side. Each angle and its opposite side has an altitude. Sometimes that altitude can be difficult for us to find and draw until we get used to it. And a lot of times it has something to do with just the shape of the triangle. So take a look down here. I have a triangle that what many people would recognize as an equilateral triangle. So there's an altitude that goes from that vertex to there. There's another one that goes this way, and another third one that goes this way. As you can see, they all meet in the same point. Now, triangles can lean over like this, and we can create an altitude that goes from this vertex that's perpendicular to the other side. It's upside down for us. But if you take a look at this point and this opposite side, let's change colors here, and this opposite side here, the altitude's not going to be perpendicular. That doesn't make sense at all. So what ends up happening for a triangle like this, and we'll look at it in class, is that we extend the side out like this, and this ends up being the altitude on the outside of the drawing. So you can see that the altitude gets a little bit troublesome on some triangles. Let's look at the characteristic. A perpendicular, the characteristics of a perpendicular with a triangle is it's perpendicular to a side. Okay, we know that. That means it forms right angles. That's going to be helpful to us if we remember that to writing equations about angles. Each angle has its own, right? So there's three of these things. The height of the triangle, the distance from the vertex to the opposite side, is known to be found here. So if I wanted to know how high this triangle is, then I would have that height there. Let's take a look at a perpendicular bisector. So this is a segment that does not come from a vertex. It basically is just a segment that's perpendicular to one of the sides, and it bisects the side. So now I could draw a lot of perpendiculars to this side. There's one here and so on. There's lots, there's an infinite number of them, but there's only one that goes through the midpoint. Let's look at the characteristics. It bisects a side. It's perpendicular to a side. Each side has its own, and it means each side has three of these, and they all meet at one point. So if I was just to sketch it, I could find the midpoint, and then I would draw something that looks like a perpendicular for that side. How about this one? Find a midpoint and draw a perpendicular. Okay, so there's three perpendiculars. Each triangle has three of them. Each side has its own, and they all meet at one point. All right, and the last one is the mid-segment. Now, a mid-segment is a segment that connects two midpoints. So each side has its own midpoint, right? And when I connect it with a segment, that's called a mid-segment. Now, a couple of characteristics that we should know by this is that it bisects each side. Each two sides have their own. So that means given any two sides, there's another one, right? So there's basically three of these things. And then the mid-segment is parallel to its third side. So this green mid-segment connects two sides, and it's parallel to the third side, the side that it's not playing with. Okay? Each mid-segment, for instance, here's a midpoint, and this one down here, we'll call this one the midpoint. That segment right there is parallel to that side. Okay? So we need to keep these characteristics in mind as we move through this section. Part of this is going to be coming to us through practice, and some of it's just memorization. Well, that is it. So in a moment, I'm going to show you your do-it problems. I'm going to encourage you to listen to some of the ideas that I have for doing the do-it problems so you can come in and do well with this. Okay? Write yourself a summary real quick and solidify some of these ideas, and then start on your do-it problems. Okay, let's take a look at the do-it problems real quick. We got AD as an altitude. Okay, so I have some characteristics of an altitude. First of all, I know an altitude comes from a vertex, but most importantly, like in this problem, it creates a perpendicular. Okay, that's what an altitude does. So what that's telling me is that that angle right there is how many degrees. That's what I want to know. So since I see an unknown, I'm going to write an equation. Now we know that when things are perpendicular, they're 90 degrees. So I want you to use your problem solving skills to figure out what kind of equation you're going to write to solve for x. Let's take a look at this next one. Find the measure of AC if BD is a median. Okay, so we know it's a median. So go back to your characteristics and see what it is that a median does. Now I know that's a midpoint. So go back to your characteristics in your notes and see if that will give you information enough to write an equation to solve for x. And then I want you to find the measure of AC. So don't forget to plug in. Problem number 3. BD is an angle bisector. Let me correct the notation there. It should have a bar above it. X is given, BD is an angle bisector. Okay, find X. Okay, so since that's an angle bisector, I know that that is going to create some congruent angles here. Now, that's not going to help me. If you take a look at the numbers that are in the problem, they're all side lengths. Now, if you go back and look at your notes, there was a secret that I told you about that, about those side lengths, an equation that will help you write an equation and solve for it. If you're not sure how to solve an equation like that, Google solving proportions. Okay, and then the last one is this one here, where it's given that AD is an altitude. Okay, ADC is 3x minus 3. So I want you to put that information into the drawing and then see if you can write an equation and solve for x. You've done a great job. We're here at 11 minutes. We're ready to bug out, and I'll see you next